Hey everybody. All right, so pause the video and try the do now. So the first thing you should do when it's asking about limits, so plug in, right? The limit from the left, limit from the right. So if I plug into the top, I get 3 times 1 minus 2, which is 1. I plug into the bottom, I get ln of 1, which is 0. So the limit does not exist. Right? So it's not 1. F is differentiable. Well, if the limit doesn't exist, it can't be differentiable. So then this next one says the limit from the left of the derivative equals the limit from the right. So we know it's either going to be A or C, right? It can't be those. All right, so let's take the derivative. F prime equals 3 when x is less than 1. And then the derivative of the bottom is 3x minus 2. Derivative of the inside is 3 when x is greater than or equal to 1. So the derivative from the left is 3. If we plug into the bottom, we get 3 over 1, which is 3. So the limit from the left and right of the derivative does exist. That does work. So the answer is C. All right, so you have a packet. I'm going through the first 2 problems in your packet. So make sure you have that out, print it, or whatever. So these problems, we haven't done any quite like this. They're basically a mix of Riemann Sum problems and accumulation problems. So that's the focus for this week. All right, so it says the graph of the velocity of a car traveling on a straight road 0 to 50 is shown at the right. Okay, so a lot of times what I do is I read through the problem, feet per second, 5-second interval, so it's a consistent interval. That's important. During what time interval is the acceleration of the car positive? Well, they're giving me velocity, right? So where is the acceleration positive? So that would be where v prime of t is greater than 0. So that means v is increasing. So where is v increasing in the picture? So that would be from 0 to 35. And then union, 45 to 50. Give a reason. Let's see, what did I write? Since v of t is increasing over these intervals. And that's pretty much it. V is increasing over the intervals. And we'll look at the actual answer key and what the answer key says. All right, B. Find the average acceleration. So remember, acceleration in this case is the derivative. So they're asking about average derivative. So that would be like your f of b minus f of a over b minus a. All right. So I'm going to do v of 50 minus v of 0 over 50 minus 0. I'm going to look at my table. V of 50 is 72 minus 0 over 50. So 72 over 50, you do not have to simplify that. You can leave it. I think I wrote it as 36 over 25, but you don't have to. Find the average acceleration, and that's it, feet per second squared. That's it. C, find one approximation for the acceleration at t equals 40. So we're approximating the derivative. Approximating the derivative, again, is like f of b minus f of a over b minus a. So whenever you're approximating, right, this is always an approximation. So I'm going to pick something where 40 is in the middle. So I used 35 and 45. So that would be v of 45 minus v of 35 over 45 minus 35. So let's see, 60 minus 81 over 10, negative 19 over 10. Let's see, show computation used to arrive at your answer. And that's it. So this is an old problem. I think this is from 1998. So this is pretty straightforward. We see a lot harder versions of this in the newer with the more newer problems. Right, and D. Approximate 0 to 50 with a Riemann sum. So this is I picked this problem, Riemann sum, 5 subintervals using correct units. So midpoint. So midpoint means we're going to skip over. So I always kind of draw in these little rectangles. There's 1, 2, 3, 4, 5. I'm going to do that on both sides. 1, 2, 3, 4, 5. And I'm going to check the width. So in all of these, oops, I thought I made that not so it didn't move. That's 10. Oh, my writing is terrible. 10, 10, 10, 10, and 10. So they're all 10, which is nice. So I'm going to do 0 to 50. V of t dt is approximately. So my width is 10 for all of them. And then I just need my midpoints. So the midpoint is the middle. Instead of using left or right, I'm going to circle all the ones I'm going to use. So 12 plus 30 plus 70 plus 81 plus 60. Now, on the AP exam, you can actually leave it like that. You don't have to simplify it at all. I did simplify it, and I got 253 on the inside. So 2530. And then it does ask for use correct units. So if I'm integrating feet per second, right? If I integrate feet per second, I get feet. And that is the change in the position, right? It's the change. This is feet, right? It's the change in the position from t equals 0 to t equals 50. And that's it. So this is a pretty straightforward problem. No like big questions in this one, I hope. All right, so let's look at our answers. So for A, they gave us acceleration is pot, so 0 to 35, 45 to 50, because the velocity is increasing, right? So that's what we said. You get 1 point for the 0 to 35, 1 point 45 to 50, and 1 point for the reason. And you can put inclusive or not inclusive. They don't take off points for that. All right, for B, 50 minus 0. Yep, that's what we did. The 50 minus 0, the average answer, done. So it says difference quotient, for example. So they gave a lot of different ones. I think it's a little weird that they did the first two. That's odd to me, personally, because you would want 40 to be the center point, so it's the most accurate. But again, this is an old problem. It's like 20 years old. So we had the bottom one. I think I also did it from 30 to 50. So that would be another option. I don't know where they got this. I was looking at this. I was like, I'm too lazy to put in some real effort on that. All right, midpoint rule. So they do this a lot. So that's a helpful method also to kind of show your work, to make it clear what points you're using, especially in case you accidentally write the wrong number. Like you wrote, instead of a 12, you wrote 0 by accident or something like that. So this actually, I disagree with this. I feel like because this is an old problem, it says the total distance traveled. It's really the displacement, though, because we're talking about, it's not the absolute value of the velocity. So I'm not sure if they put out, like, commenting on this later, because it shouldn't say total distance traveled. That would be absolute value. So I'm not really sure why this is the case, but again, this problem is from 1998, so. All right, so I want you to pause the video, read through the problem, see how much of this you can get through. This, again, is a pretty straightforward problem, in my opinion, a little harder than the last one. So let's go through it. The rate at which water flows out of the pipe in gallons per hour is given by a differential function. Circle that. They don't tell you that for no reason. My guess is at some point we're going to have to say R of t is differentiable. It's very, very likely. Use a midpoint Riemann sum with 4 subintervals. So again, I'm going to break this up. 1, 2, whoa, okay. Make my subintervals correctly. Okay, those are my 4 subintervals. Let's see, 6, 6. So they're all 6, which is nice. And I'm going to do the same thing over here. Those are my 4, and I'm going to circle my midpoints so I know what points I'm using. So let's see, 0 to 24, R of t dt is approximately, so 6 times 10.4 plus 11.2 plus 11.3 plus 10.2. Or you could put in v of 3, okay, plus v of 9, plus v of 15, plus v of 21 to make it really clear what you're doing. And plug that in your calculator, and you get 258.6 gallons. All right, we're integrating gallons per hour, right? Gallons per hour, so we get gallons. Explain the meaning of your answer in terms of water flow. So the 258.6 gallons of water. And then let's read the problem again. The rate at which water flows out of the pipe. Flowed out of the pipe over 24 hours. Oops, not 25 hours, 24 hours. Okay, sorry my ratings. I missed my whiteboard. All right. The rate at which, again, same problem. B, is there a time from 0 to 24 such that r prime of t equals 0? So think about what that means. The derivative is equaling 0. So does that have to happen? So what I did for this is for the derivative to equal 0, remember differentiable. I'm thinking one of my formulas, or one of my my theorems that I know. So if you look up here, I saw 9.6 and 9.6. If you do your average rate of change, r of 24 minus r of 0 over 24 minus 0, you get, I made you so you weren't supposed to move. 9.6 minus 9.6 over 24 equals 0. Now, what's our justification for that? So I have a yes, and the reason is the mean value theorem. Since r of t is differentiable, and that's why they gave you that, is differentiable, there must exist a c such that r prime of c equals 0, right? Our average rate of change equals 0 from 0 to 24, so there has to be a point. Now, you could go through if you wanted and you didn't remember mean value theorem. Let's say you could write an explanation talking about increasing and then decreasing, right? This is a differentiable function that goes from, the rate of change is going from increasing to decreasing. So because it's differentiable, at some point the derivative equals 0. You do not have to actually say mean value theorem. Did I even say mean value? Yes, since R of t is differentiable. I would also throw in MVT. Must exist and based on the MVT. Based on MVT. Again, you don't have to do that, but I think it's a really good, like if you don't come up with MVT, it's perfectly fine for you to just explain using correct calculus. All right, C. The rate of water flow can be approximated by Q of t. Use Q of t to approximate the average rate of water flow. Now, this is the hardest part with this. The average rate of water flow. All right, so what is this actually asking? The average, what is rate of water flow? Rate of water flow out of the pipe, that's R of t. So this is where it can get confusing between average rate of change versus average value. This is actually referring to average value. So we are finding the average value. That formula is 1 over b minus a, the integral from a to b, f of x dx. So we're going to integrate from 24 hours, 0 to 24, 1 over 24, q of t dt. And I just plugged it in my calculator, and I got 1 over 24 times 258.835443, which equaled 10.785. And then it wants units of measure, gallons per hour. Right, so this is over hours. And then the integral of gallons per hour is gallons, right? So gallons per hour. Approximate the average flow, indicate units of measure. So the average rate of water flow from 0 to 24. Does it say explain? No. Okay, so that's it. We're done. All right, and here is our answer key. So again, notice I brought that up. The approximation to the total flow in gallons per water. This is an approximation of the total flow in gallons of water from the pipe from 24 hours. So again, use that word change. The word change is really good. So they say MVT or equivalent for B. Like I said, if you want to talk about the fact that it's differentiable and R is increasing and then decreasing, that's completely acceptable as well. And then it gave us 1 point for all the units. So that's really common. You'll see where one of the problems, there'll be 1 point for all the different units. All right, so I want you to finish this packet. Please do number 3 at the minimum, please, or letter C. Do problem C for tomorrow during our class. It's the hardest in the packet. So I want you to do C so we can talk about it during our group chat tomorrow. All right, email me if you have questions. Yeah, that's it. Have a great day, guys.